Good morning, ladies and gentlemen of Algebra 2 Honors. Good to have everybody here today. Good to have people who today here who were missing yesterday, except for Marcus. I heard he'll join us. We'll see. Okay, so yesterday, starting on factoring yesterday, what we did is we talked about these three techniques that are ones that you should have already been to some degree familiar with already.
Yeah.
And so what we're doing is we're sort of reinforcing in this exercise set all these things. And then after that, we're going to launch into the meat of chapter 7.3, which is going to bring these methods along for a little bit more advanced factoring. So that's kind of where we're headed today and Monday. And so we have this first problem here was worked out using greatest common factor first, and then factoring this quadratic trinomial. And here is a box method demonstration of the factoring of this trinomial here. And we did problem 2 yesterday, which is one where you did a greatest common factor, and then we used this bottoms up method to factor this more. Whenever you have a quadratic trinomial with an x squared greater than 1, that's another level of complexity that can be addressed by this type of x method or bottoms up method. And then finally we left it here with problem 3, which was a greatest common factor, and after you have the greatest common factor, there's really no farther that we can go in this, right? Is everybody okay with that?
Yeah.
Okay. And so now we go on to problem, this is where we left off yesterday.
Yeah.
So we get on to problem 4. And so for problem 4, what is going to be the first thing that you look at? See if we have a greatest common factor, right? And so what would be a greatest common factor here?
4.
So 4, good.
4.
And I'm glad that you considered that as first on the list. So if we factor out the 4, what do we have left? 4x squared minus y squared. Okay. So now we did the greatest common factor. Now, is this a quadratic trinomial? No, it is not. And so the next thing was, which was number 3 on the list, was called a difference of squares. We'll go right back to it here. It is this thing here, a difference of squares. And what you do is you look and you see, well, you can take this thing here and factor it out if you can you write it like this, and then you put a plus minus like this. And what you do is you could take, I'm going to color code a little bit. You can take this, if you can take the square root of this, you can put this first, you can put it here and here. And what's going to be the square root of 4x squared? 2x. So I can put 2x and 2x here. And the next, if we can take the square root of the second term, what's the square root of y squared? Y. So we can put y here, and we can also put y over here. And so this would be our fully worked out factoring of this. Pardon me? Somebody mentioned a box method?
Yeah.
Well, you really could do it, but if you talk about box method, you really could. Let me show you how that works out. Somebody mentioned it. So what you can do is you can work it out with a box, because if you put 4x squared here and then y squared here, what are going to be your factors of 4x squared? Well, 2x and 2x, right? And what are your factors of y squared? Y and y. And so what you have is you have a situation where you don't have anything in between, so you need to go ahead and you need to make one of these negative, so that way you have 2xy, or excuse me, negative 2xy, and you have 2xy here, and these will cancel, and that's how you end up with that.
So wouldn't that be negative?
That's what I thought.
Y squared?
No, y squared will be what happens is, yeah, that'll be negative y squared, thank you, because you have negative y times y. Thank you for catching that. Yeah, and so you get 4x squared minus y squared. And the one thing you can get into is a common mistake is that if you ended up factoring this out and you had, like, for instance, 4x squared plus y squared, would this thing here, would this thing be factorable? No, it would not. This would not be factorable. So that's one kind of misconception that you can run into. So just watch and make sure for difference of squares that it is in fact a difference or a minus sign between the terms. Okay, so are we okay with that? Any questions on that one? Okay, let's get on to the next one here. And so let's get to this one here. So I want you to go ahead and work out this. See if you can factor this. I might spin the wheel on this guy today.
The wheel was key.
So we'll just a minute.
What's going on talking? Was it
It's A and C.
A times C or A?
A times C.
It's just 13. Negative 13.
So everybody here except
So what multiplies? So what multiplies to 30? What multiplies to 12 and adds up to 30?
Hey, nobody said full.
all right, let's go ahead.
So 6 times.
Nothing adds up to that.
Okay, let's go ahead and see here. Marcus, we know Marcus. Well, Marcus.
No, it's supposed to be.
Yeah, we're gonna move Marcus across the room. I can't sit down.
I was like, boy, I kind of marked it to the name.
No.
It's gonna be Randy.
Yay, yeah. I'm stoked.
Randy, I heard a lot of debating about this one. Did you come up with this? Randy, did you figure this one out?
I feel like it's no solution.
Oh, really?
Yes, because there's 13.
I need some solution.
It's a prime number.
So,
Okay. Well,
Or you.
what if I told you?
13 times negative 1, which would equal
13.
Yeah.
13 times negative 1.
13 times negative 1 equals 13, and then 13 minus 1.
Wow.
Okay, Randy,
I
tell
didn't
me
like that.
tell me what you had. You figured it out?
So I did the box.
Oh, you did a box like this?
Yes.
Okay.
I don't know how to do the bottom. And then I put
perfect,
X squared,
perfect.
and then 13 x and then negative 1 x.
Have I ever done that? No.
Not 13.
Not really.
Or 12x.
Right.
Sorry, 12x.
It's not 12 like this.
Yeah. Oh, okay.
Yes, and then next in between, or the top right box, I put 12x.
Well, 12x here.
Would it be 13? Yeah, it would be 13x.
Oh, 13x.
There's no
Oh, sorry.
13x. There's no x after 13.
It should be negative.
And then
Wait,
the next one would be negative.
I'm
It
so
should
lost.
be, what did it be?
Whoa.
Wait, don't we have to do
What?
the factors of 12?
Wait a second, we got, let Randy's in charge right now.
Yeah.
Go ahead, Randy.
And then the empty box would be negative 1x.
Okay,
Wait, I have a question, Mr. King.
So then
Shut up.
go
I
ahead.
have to leave this
that would
guy.
be plus 13.
Okay, so 13 up here.
And then negative 1. So then
You're
the.
at 12.
Well, let's try this out. Well, so if you take 13 times x is 13x, and 13 times negative 1 is negative 13, x times negative 1 is negative x, and so you combine these together, what do you end up with? 12x, right? So out of this we have x squared plus 12x minus 13. So therefore, this is our fully factored form, right?
Wait, Mr. You can ask my question?
Oh, no.
Yeah, go ahead, huh? Now it's time for it. Yeah, go ahead.
Don't these two have to add together to make 13, negative 13?
No?
But multiply to make number.
Yeah, where did 12x go?
It's a
13
13
x
x
Because yesterday we did it where the two across had to multiply to equal 12 and then
Yeah, so
add to equal 24. Yeah.
so what it is,
I don't understand this. That's why I'm asking why.
it's the answer to these numbers, 13 and negative 1 are the answer to the question. Okay, here's the question. What two numbers which when multiplied together equal negative 13, yet when added together equal 12? Okay, so that's what it is. Does that make sense?
Yeah.
Okay, any other questions about that? Okay, good. So these are some good things that Atlee and others are asking, right? All right, thank you for that. Okay, thank you. And it's really kind of the way she did. She looked at it and said, "Oh man, I don't think it's possible." And then she got working on it. That was really good work. Okay, let's get on and see if we can get this next one here. We'll take care of this. All right, next. I want you to go ahead and work out number 6. Now, I will tell you number 6 is going to require like a more complex type of arrangement, maybe like a bottoms-up method.
Bottoms up.
You can do it without the bottoms-up method, but then there's, I know Bryce liked that yesterday.
Which,
Yeah,
which,
I did.
the two I said?
I didn't switch them.
No, and the reason is that 2 is a common factor, and 4x is a factor of 4x squared, but not for those other two. Not for 9x or for 5. So you can't draw 2 out of it. That's
A plus
Nothing, can't get it.
Yeah.
It's A times C.
that's what I said. Thank you.
I would recommend is drawing your X, put AC on top, put B on the bottom. And AC would be 20. So what two numbers, which when multiplied together equal 20, but when added together equal 9?
Guys, I know the answer.
Oh, I get it.
That was not right.
20. Oh, it's 4 and 5.
4 and 5. 4 times 5 is 20, 4 plus 5 is 9.
So would you just put 4 and 5 on the side?
But what do we divide by? We're supposed to divide by 7. Divide is not probably divide by 6, because there's a lot of 6.
Yeah.
Divide by.
I think you divide by A.
By-
You divide by A? Yes.
Just divide by 4.
Divide by
You divide by
4.
8, yeah.
Shut up,
Is it 4?
Yeah, it's divide by 4. Yeah, that's what I was-
This.
You don't do that, you put sand in?
I'm at,
Trash ball.
Yeah, you look at it.
is it,
What's working on?
I don't know.
So we're going on.
is it mine?
Plus 5 on 4. So 5 on 4.
Is it X?
How did that just turn into that?
Did you, Aaron?
So
Did you miss
We
watch the last video yesterday?
No, I didn't get the message coming.
Have you signed up for it?
Oh, so it's.
By 4
Yeah, I'm
steps.
sending these things out.
4x plus 1?
Class, Aaron says he didn't get a remind message yesterday. Did anybody?
I
Did you
I
get it?
got one.
I did, I remember, because I
So
walked
you
in my
might want to sign up
door.
again or something.
Yeah, I didn't get one.
You didn't get it. So I,
Bless you.
I'm pretty sure it'd be 4x plus 5 on the first one.
Jose, you got, were you able to look at the video, Jose?
No, I was too busy.
You're too busy, okay.
What was the
It was just a video. I tried to text you back, Mr. G, and ask you a question, but it said, nope.
Yeah, that doesn't have that flexibility. But what you have is you have my email address, right?
Yeah.
You can email me.
Yeah.
What are your numbers?
So do that. Okay, I'm gonna call on somebody. And I realize that whoever I call on may not have all but done, but I hope it's enough to at least get started, right?
Dude, I was just...
Let's go ahead.
X plus 5.
That's not bad.
Let me Cheyenne or
Of course.
Bryce, Cheyenne or Bryce, Cheyenne or Bryce, Cheyenne.
Of course.
How did you do that?
All right, Cheyenne, what did you?
Why would it be?
That's what I got too.
It's,
Mindy, you got
I got X plus 5.
I got 4x plus 5.
Okay, Cheyenne, what did your, what'd your left hand come up with here?
I drew the X,
What's
Okay,
your left hand?
and I did A times C at the top, which is 20. And then B at the bottom, which is 9. And then I found what, when multiplied 4 and 5,
4 and 5, okay, like this.
Yeah.
and divided by 4.
Divide by
4.
4.
that one you did?
And this one here simplifies to 1. So we can write this as x plus 1, x plus 5/4, right? Okay, then what?
And then, so the X plus 1 stays the same, because we need the bottoms out.
And then you bottoms up this guy here.
Right, and you bring the 4 over, so it's 4x, and you leave the 5.
So this is your factoring here.
I get that, yes.
Right, looks good. Kendall, how did you do on that? You come up with that?
No, she's just talking.
That's what I got. That's what oh no, Mr. G. I got
Oh, Mr. G, how did you
5x minus 4.
No, that's not right.
No, that's
Well,
not right.
okay, I get that.
I did it the opposite way, but I got the same answer pretty much.
Oh, what did you mean? What do you mean opposite way?
I put the 5 over on the left side.
Yeah, that doesn't matter, right? Yeah, and it doesn't matter because of the what property of algebra?
The reciprocal.
No? This is gonna be on your final. I was looking at your final. It says, which property of algebra doesn't, it doesn't matter which order. Starts with a C. Commutative.
I never heard that before.
Property. It's gonna be on your final. It's gonna be on your semester final.
When it did that,
I've never...
what did it?
Or distributive
Mr.
property.
Lee, is it gonna be, how long is it gonna be?
30 problems, yes.
Are we gonna have a review?
Yeah, we'll have a review.
No, good.
Yeah.
Open note.
I'm gonna
Mr.
fail.
G, you should do this.
It's
No, I don't ever talk to Mr. G.
Can you explain that one to us?
Wait, so is it gonna be like
Subproperties,
because we never
what is subtotal?
it'll be distributive and commutative
Right, what's subtotal?
that's
like
When I was gonna turn around.
Gee, I should be bad.
probably most important.
Mr. G.
Subtle. It's S-U-B-T-O. I know.
Can you give me that?
Sure.
Like $5.
Subtle.
Steal it, dude.
Subtle.
Subtle.
Sub.
Subtle.
Sub.
Mr. G, how,
Yes.
And Deshaun, like, what did he say yesterday?
Subtle.
Elbow,
Mr. G,
I see, like 4x.
How do we end up with 4x? Cheyenne, you got a follow-up question to this problem here.
Okay.
Siggy asked how you ended up with 4x on this thing.
Okay. I did bottom this up, I brought the 4 over. I don't know how else to explain.
Oh, okay.
How'd you get
Like, I took the 4.
So
and I
4,
brought it-
Yeah, you brought it up.
4 goes like
Because it was
it.
on the bottom, so I brought it up. So
There's your bottoms up.
There you go.
Okay?
I don't know.
Did I ask your question? Thank you. Thank you, Cheyenne. See, you all right?
You're welcome.
Thank you, man.
All right, let's go on to the next one here.
Can your Henrietta Lex be like?
And another thing you can do, and before I became a professional math teacher, what I would do, I used to factor this thing just by trial and error. That I would put 2x and 2x and I would work back and forth. But this is a hard one to factor by trial and error. Actually, the 5 and the 1 are going to be easier over here. We know that's plus and plus. And so what you have to do is work with factors of 4x squared and just trial and error it till you get it. So you can work it out by trial and error, but it might take more time. All right? Let's go ahead and do this next one.
This is gonna be like,
Okay,
My own soil.
so which technique would you use on this one?
Bottoms up.
No, I would probably try to find a greatest common factor.
Okay, first, Atlee said the first thing you would try to do is find the greatest common factor. Very good. And so what would the greatest common factor for this be?
2. Nope, just kidding. 4. Just kidding. 3.
There is one.
Just kidding.
There is no greatest common factor.
So there's 4.
And then you look down the list for number problem 2. Is this a quadratic trinomial? It is not. Then look at number 3. Number 3, is this a difference of squares? Yes, it is. So if you just kind of go down the checklist, you can factor these out pretty well. So I'm going to go ahead and choose somebody for this.
Wait, hold on.
So there's no greatest common factor?
Well,
Can you say all that again?
That'd be
Well, I don't know how to do difference of squares.
Listen.
okay, look it. Let's go back here.
I don't like that.
Let's go back in time.
Number
5.
5 shows it.
No, not number 5.
Well, actually, I need to go back here. Let's see if I can go back in time to this thing here.
I don't have a body.
Oh, no, I can't do that. Okay, let's go back in time to this one. We turn back the hands of time to this problem right here. Greatest common factor of 4, right? So we have 4x squared minus y squared. Does that remind you of what we did earlier?
Yes.
Now we factor this out. And this thing here, this thing right here, is a difference of squares. We got a difference. What tells you this is a difference? A negative sign. What tells you this can be a difference of squares?
Squares.
This thing can be a square, can be 2x squared. Can this thing y squared be a square? Yes. What squared? Y squared. Now that's turning back the hands of time. So let's go ahead and go forward to 9:13. To 9:13 a.m. Okay, we went back to 9:05 a.m. We're fast forward to 9:13 a.m. Okay, is this a difference of squares?
Yes.
Or can be written as a difference of squares? So use that technique. I'll call on somebody here in the next half
So it's
minute.
gonna be 2x and minus
What
11.
is 9:13?
The time.
Right.
Guys, Miss Tucci is just cool. You just read this.
He just knows how to do it.
That's about 121.
two.
I just don't understand what he was talking about.
Yeah.
B subject to.
Yeah, 2x plus.
He said, should I have the biggest one?
No, dude.
That's not. That's all.
And I hope it pierces your mind.
Okay, here we go. We spin the wheel.
That's on me.
Alright.
Yep, sorry.
Let me Jose.
Oh, say. Oh, say.
Jose.
Which one, dude?
B subject.
All right, Jose, how'd you handle this?
Okay.
I was just.
Okay.
Don't hear.
To be honest, I don't understand.
It happens to like.
Yes, you do.
No, he doesn't.
Neither do I.
Okay, so do I turn do I like kind of wherever we go, the negative 121?
Kinda, no, you do.
No.
Yeah, okay, you can do that. Yeah, so let's give you a square root of that.
Ignore him.
And then that's e to that, and
11. So we put 11 here and 11 here. Okay, good. What next?
And you kind of like separate the 4x squared. I don't know how to explain it. You just like divide it. So then it turns into 2x.
So you take the square root of this, is what you're saying, right?
That's how I'm explaining it.
So you get 2x and 2x. What's next?
And then one is plus and the other one is minus.
Wow, you're smart.
Okay, so that's it, right?
Wow.
Okay, so
Wow.
so he explained it step by step. So I called him. He said, "Oh, I don't really know how to do this."
Yeah,
But then he just thought through how to do it and did it, right?
You're so smart.
He's just smart like that. Like, I don't even.
Yeah, I did it wrong.
Somebody worked out box method.
I did.
Did it work out too?
Yeah.
Yeah.
Yes.
Yeah. Okay. Well, that's good work, Jose. All right.
Accidentally.
What I want you to do is go to number 8,
Good job, full C.
So,
and I'll call on somebody here in
cool.
Number 8 is the exact same.
That's
a minute for number 8.
Hopefully it's me.
alright.
And where's your greatest contact? Is it
You know
me?
what?
Looking forward.
What is it for?
I can see it in your eyes.
Actually.
Actually, it's 4.
It could be.
That's what I meant.
It can't. It has to be the greatest.
No, I'm saying it. You know what, Ali? Rest. Don't.
Hey, did I just do this or does it have to do
You good?
So,
Try not to read this, Chief. Try not to read.
oh,
You
you're
walk
left.
around and read it.
It doesn't work very well.
Yeah, it
There's
What did I do?
continuous oxygen is needed for brain function and for life.
we don't really care.
You
can read around this.
I think we're supposed to check it and there's like the double parentheses.
Okay.
Yeah, mine.
That's what it did on that
All right. So let's go ahead and choose somebody
I'm
here.
just glad I already went.
It's gonna be me.
There's a
Mine, it'll be at me.
Atlee.
I didn't laugh.
This is why I should.
Atlee is usually a task. All right, Atlee, how'd you handle this one?
My mom did know. My mom. Can I, so the greatest,
For what?
What is that great job? What did you do?
the greatest common factors.
What?
And then, I'm in parentheses,
It's not expected, it's just.
x squared minus 1.
I didn't know what about that.
All right, good, all right. What next?
Cash it?
That was
Yes.
What next?
That's all I did.
Yeah, there is a next.
If you make it
told you, you got
closer.
no parentheses.
Who can help me with the next? Thank you, that was good so far, though. You got a great, I'll give you credit for that. What's the next thing? There is a further factor. What is it gonna be?
Hold on.
X, would it be
4x.
x squared plus 1 and x squared minus
4
1?
parentheses.
Or x plus 1 and x minus
Parentheses x.
Oh wait, I can take it
Plus
from
1 x
here.
minus 1. Yep, told you.
Good.
See, I have that.
Wow.
All right,
Only there was double parentheses, didn't I?
Indeed.
so here's an example of a combination, right?
Calm down, choose the greatest.
Yeah, hit this, look. don't know if that's wrong.
What'd you get?
I didn't do it.
I guess I got what that answer.
Yeah, okay, yeah, let me show you something too, because Siggy had a good idea on this too. Yeah, he did.
Oh, I gotta stop. I can't. Is that from yesterday?
All right. All right, Siggy had a different approach here, and let's talk about that because I think it's worthwhile to figure out what's going on. What he noticed is that this thing actually is a difference of squares, isn't it? As is, before factoring out a greatest common factor. And so this can be rewritten, and this is what I saw in Siggy's paper. It said, okay, square root of 4x squared is going to be 2x, and then we have plus or minus, and then square root of 4 is 2, and so that's it, right?
Yeah, I did everything by turning, I think.
But what is wrong with this?
It's not the greatest common factor.
It's not fully factored because you have a common factor of 2 here and another common factor of 2. So this could be 2 times x plus 1, and this is going to be also 2 times x minus 1. And so 2 times 2 is 4, so you end up with 4 x plus 1, x minus 1. Now you can still get there, right, by doing it in a reverse order, but can you see that I feel the complexity is reduced by factoring out the 4 first, if that's possible.
Yeah.
Well, I still think that's a good insight, Siggy. I appreciate you bringing that to our attention. I'll give you credit for that. All right, so that's good. So it's some deep thinking going on here. Okay, let's go on to number 8. And I will call on somebody here.
Nine.
I don't laugh like that. I don't laugh like that. I
Why
hate
did I
my
go
own.
from-
Stop laughing.
I'm glad you know what you're doing. I know.
I usually don't have like
Shit.
All right, number 9.
Hold on.
Okay, number 9, here we go. We got,
I was still. This head one.
it's
Yeah.
gonna be Chloe, all right.
Hey, where's Mark?
Oh, we tested it today.
All right, Chloe, how'd you handle this?
I did the box.
Nice.
So you went on a box like this?
Yes.
Man, that is an ugly box. Here,
I did not do the box.
Well, what we did.
I did.
No, I'm just saying, is it okay if I didn't do the box?
Yeah.
all right, go ahead.
And in the first box, you put x squared. And in the bottom one, you put 18.
Okay,
And then I figured out that 18 plus 1 equals 19. And so I put 18 and 1.
so 18 here and 1 here.
Yep, and then I just filled it in. And then I checked and it was right.
So you checked it was right. So you got this right
Good
here.
job, Chloe.
Nobody said good job.
Good job, Cheyenne.
Too late.
We don't have to.
Okay, so that's it, right?
Nobody likes that.
Okay, why don't you go ahead and do number 10?
Mark does not like that.
Take his question, and it's all right.
In this case, when you do your AC, it's going to be a little larger to deal with here.
Dang, dude. I do my box and I can't even do it. Dude, I gotta do this X now. Y'all ever have those goosebumps that hurt?
What you write? You write 5x.
Okay, let's go ahead here.
Pee my pants.
It also comes to 18.
Gosh. All right, let's go ahead and shuffle this one up here.
Where? Okay.
Let me Siggy, all right, Siggy.
I could have sworn Siggy. Did you not go?
You got me playing.
No.
All right, go ahead.
Yeah, I don't know how to do this one.
Oh, really?
Yeah, I really don't.
Oh, it took possibly.
What I do, bottoms up or?
I don't either.
Has anybody figured this out? So
Lexi
few of you
I
have.
did.
Lexi, have you figured it out? You
I
pick.
figured it out. I think it's worth it.
Are you free?
You ready to work this one out, Lexi?
Secretaries call me backwards too.
I did the bottom something.
Bottoms up, okay. So you made an X like this.
Is that right? Like, can you do the bottom?
So you got, did you finish it?
No, but I put 90 in the top.
So bottoms up, let's go.
Well, you put 90 up here
90.
and negative 33 here. Okay.
And then I figured out that negative 30 times negative 3.
Okay, is that good so far? Looks good to me. And then divide by 5.
Yes.
Divide by how much?
And so on the left you get
Because he says.
negative 6, right? And so you have here x minus 6, then also x minus 3/5. And so what do we do next?
I got
Boom, boom.
x minus 6, 5x
Yeah,
minus
bottoms up.
So is that it? Yeah, that's it.
6.
Wow. Awesome.
Yeah, it is all.
Great.
And we're getting close to the end of class. I do want to talk very briefly about what's kind of where we're going to be headed on Monday. So just, if you can just stick with me for a few more minutes, I appreciate it.
When are finals next week?
We'll pick these up very end of class. Okay, stay with me, everybody. Stay with me. Class is still in session. Stay with me. Okay. What we have is this gets us an introduction to 7.3 factoring polynomials. And we go here and it starts talking about types of factoring. It says, here's explain one, factoring out the greatest common monomial first. And here they give this example of 6x cubed plus 15x squared plus 6x. And your greatest common factor here is going to be 3x. And so after you factor out 3x, you have this left. And then you can factor out with simplest terms. And the way we did it in class today, you would have used like your x method to get from here to here, right? So really this is assuming what we've done today. Next, we come here, we have this one right here. Real numbers and integers, talk about that. Okay, your turn. So let's go look at this one right here. How would you factor this one out? You got 3x cubed plus 7x squared plus 4x. What would be your first thing to do here? X, right? So x is your common factor. So you have x times, or excuse me, I put an equal sign. So you have x times 3x squared plus 7x plus 4, and then what? The way we've done it is this, right? And then what goes here? 12, what goes here? 7, what goes here?
3, 4.
3 and 4, and then what?
Divided by 3.
With 3, so equals 1.
So 4.
So we have x plus 1, and then we have x plus 4/3,
3x plus 1.
and so we have
X is 1, and that's 3 X is 4.
3, then we have 3x plus 4. So we're going to have x times quantity x plus 1, and we have 3x plus 4 using the bottoms up method. And so that's how we have that, right? Yeah, so anyway, we're going to be recognizing special factoring patterns and really launching to this on Monday. Okay, difference of squares, we've done that, right? Perfect square trinomials, we haven't done that, but that's similar. Then we're going to work on sum of cubes and difference of cubes, and there's also another method that's called factoring by grouping. So I don't know how far we're going to get, but we're going to leave it there today. Thank you. Appreciate you being in class today.